All right, so the recording has started, so let's dive into today's lecture. Now, remember, this was the earlier notebook that we were looking at when we were looking into what can we do in the feature, how do we select features, right, Nakina? So basically, you have a lot of features, but you want to select a few features. You don't want to select all the features. You want to select features that are important. How do you do that? Now, there are many algorithms for that. So the first algorithm we discussed the last time was you should drop a constant features using variance threshold technique, right? I hope you remember that. So here was an example of what we have done. So if I run that, so this is a data frame. So look at this data frame. We have got 4 features. So I'm just looking at the features now, A, B, C, and D. If you look at column C and column D, you see that there is no variation at all, right, Nakina? Yes? Can you see that? Yeah, do you see that there is no variation at all? In column C, everything is 0. In column D, everything is 1. So if it doesn't vary at all, then there is no point of considering them as features, because they don't have any variation, so that doesn't have any impact on the target, right, Nakina? So one of the ideas is if there is low variance threshold, okay, or sorry, if there is a low variance features, you don't need to consider low variance features. You should drop that. Now we have something called variance threshold that we discussed in the last class. Okay. Now variance threshold, actually what it does, if you import from sklearn feature selection something called variance threshold. Okay. So then you instantiate a variance threshold, var thresh equals to variance threshold. By default, the threshold value is 0. That means threshold value is 0 means they don't have any variations at all. These are constant features. Okay, right? Then you feed the data. Okay, once you have done that, okay, it should actually identify which are the ones that have no variation. So these are C and D. Okay, and then you can print out all the data. Okay, and then also you can actually run a loop, and you can actually drop those ones without any variation. So you can drop C and D. আচ্ছা, এটা আমরা লাস্ট ক্লাসে দেখেছিলাম, অ্যান্ড লাস্ট ক্লাস লাস্ট ওয়ার্কশপ যেটা, সেটাতেও কিন্তু আমরা ভ্যারিয়েন্স থ্রেশহোল্ড করেছিলাম, বাট উই রোট র কোড ফর ইন পাইথন, রাইট? ডু ইউ রিমেম্বার দ্যাট নাকি না? ইয়া, আই থিঙ্ক দ্যাট ওয়াজ ইজিয়ার। মনে আছে নাকি না? ইয়া, ডু ইউ রিমেম্বার দ্যাট? ওকে, দেখে নিন। Can you guys hear me, Nakina?
Yes, sir.
Yeah. So algorithm 1, if you have any constant features, that means features in there is no variation, you should drop them. So that's first one. Okay, you do not require those features. I'm going to now show you another important algorithm. That is, how do you select the feature using something called the Pearson's correlation. Okay, and this is a very useful algorithm. So I'm going to very quickly show you how can you use Pearson's correlation to select features. Okay, now I assume all of you have done math 361. সবাই math 361 করেছেন আপনারা?
Yes, sir.
Yeah, so because you have done math 361, where the course is probability and statistics, I'm sure you have done correlation chapter করেছেন. Yeah, you guys do correlation? Hello, you need to answer. You can't mute yourself for life, right? Okay, yeah, you have done correlation, right? Okay,
Yes, sir.
right, all of you have done correlation. All of you know how to measure correlation between two variables, right, Nakina? Yeah, you have done this in math 361. করেছেন নাকি করেন নাই সেটা বলেন?
Yes.
Okay.
Yes, sir.
So you have probably done things like let me show you. R equals to S of xy, এরকম কিছু করেছেন? Divide by root over of S of xx times S of yy, all these sort of things. Yeah, you should do that. You should have done that. ঠিক আছে, I'm sure you have done that. ঠিক আছে, এখন কিছুই মনে নাই. That's unfortunate, but anyway, I'm not going to discuss those statistical formulas of how to measure the correlation, but this is something that has already been covered in statistics course. But I'll just tell you, what does a correlation give you? Okay, so let's see over here. I want you to see this one very carefully, because this is very important. Okay, let's say I'm going to draw a scatter plot for two variables called x and y. So this is y, that's something called x. So we're saying just maths. So let's say these are some points, okay, that we have. Okay, so we've got some points. So how do you think is y varying with x? Y and x, how are they varying? Y depends on x. Y is the dependent variable and x is the independent variable. So what do you think? How is y varying with x? Sir, চুপচাপ
Y
থাকতে
equal
class
to
না
N
করে।
linear
How
number.
is y varying with x? That's the question. বলেন।
Sir, as x is increasing, y is increasing.
As x increases, y increases. Okay, that's right. And in fact, you can draw a regression line like this, which you are supposed to do in statistics as well. You can draw a best fit line like that, right, Nakina? Yes? Yeah? Can you do that? Yeah? Okay, so this is the best fit line. You can actually create a best fit line, okay, from these data points that you have, right, Nakina? Okay, Acha. Because you can draw a straight line, that means, and I can see that these points are very close to each other. I can say that the relationship between y and x is y and x. Of course, y depends on x, but they're extremely positively correlation. There is strong positive correlation between x and y. Can I say that, Nakina? Strong positive linear correlation. There exists strong positive linear. It says linear, right, Nakina? There is no circular correlation or some other kind of correlation, right? There is strong positive linear correlation between x and y. Can I say that, Nakina? Yeah? Hello?
Yes, sir. Yes, sir.
Yeah. Tikache, is it clear? Are we good? Do you understand that there is strong positive linear correlation? Yes or no?
Yes, sir.
Yeah. Okay. Similarly, let me show you another case. Okay, another situation. Another situation could be, let's imagine we've got some other x and some other y. That's some other x and some other y, and the points we get is something like this. So how are x and y related now? What is the relationship they have?
x
If it-
x
Hello?
ইনক্রিজের সাথে y ডিক্রিজ করতেছে
Yeah, so that would be, if I fit the best line, that's how the line would look like. Okay, but clearly this is also, I can draw a straight line. So the relation that we have between x and y is also linear relation, right? But it's a strong negative linear correlation. There is a strong negative linear correlation. Negative linear correlation মানে একটা বাড়লে আরেকটা কমছে. Am I clear নাকি না?
yes sir
Okay. All right. Let me draw two more cases as well, and then we'll go to what we are doing now. Okay. Let me draw another interesting situation. This would look very familiar, but let me draw that. Yeah. So let's say we have again y plotted on the y-axis, x plotted on the x-axis. Say we get something like this. So what's the correlation, do you think so? Yeah. What kind of correlation do they have? Sir, am I asking very difficult questions? Yeah. What kind of correlation x and y has? Can I draw a best fit line here or not? Tell me
No,
that.
sir.
I could draw a best fit line again, right? Yes.
Yes, sir.
So what kind of relation, that a correlation do they have, x and y? They also have a positive linear correlation, right, Nakina? Yes? Yes or no?
Yes, sir. Yes, sir.
Because if I increase x, y also increases with that. If I decrease x, y would decrease with that. Correct, Nakina? It also has positive linear correlation. But you might say that this might seem to have better, the first diagram over here, the top diagram that we have, that might have better, I mean, stronger linear correlation than this one. তাই না নাকি না এটা বলতে পারি?
জি স্যার
Because এটা কাছাকাছি to the specific line, but এটাতে একটু কিছু জিনিস একটু দূরে দূরেও আছে slightly, ঠিক আছে? So this might, both are positive linear correlation, both are strong, but that may be more stronger than this one. So not only I can say the nature of correlation as positive or negative, I can also find out the magnitude of correlation, how strong or how weak they are. Okay, is it clear, Nakina? Yes.
Yes, sir.
Yes, sir.
Okay. The fourth case that I want to show you over here is this one. So these are the things you guys are supposed to know from statistics, ekdom basic statistics. Y against X. Let me show you a fourth one, which is more interesting to me. What about now this one? What can you say? I can say that there exists no linear correlation between them. ঠিক আছে? Yes? I could have a circular correlation or other kind of correlation, but I'm interested in linear correlation, and there is no linear correlation, right, Nakina? Yes?
Yes.
Or I would say very weak linear correlation. Okay? Right? Are we good, Nakina? So far, so good? Yes?
Yes, sir.
Okay. So we have seen interesting cases that we could have. Now, what I'm going to do now is I'm going to measure, look at the first and the first case and the third case here. So this is the first case. That's like let's say the second case. Let's say this is the third case. Let's see this is the fourth case. So from the first and the third case, it's clear that both are linear correlation, but the first case is much stronger. The first case exhibits much stronger correlation between X and Y compared to that of the third case. Correct, Nakina? So the question now is, how do we measure the strength of correlation? Now, this strength of correlation can be measured in different ways, okay? In statistics, I'm sure you have learned how to measure the strength of correlation. There is a technique called a Pearson's correlation, and Pearson's correlation can be used to measure how strong the correlation is. Now, I am not going to right now go ahead and talk about those things right now, because that's something you are supposed to do in statistics course. But let me just tell you what would be the interpretation of this Pearson's correlation. Using the formula that we have in Pearson's correlation, we can find out the value of R, which measures the how strong the correlation is. The variable the correlation koto strong can be measured by this variable called R. Okay, Acha. That gives me the Pearson's correlation, let's say. And this R, okay, when you find this, its value will range from -1 to +1 এর মধ্যে range করবে. It will not be larger than 1, and it will not be smaller than -1. Clear? Okay, yeah. Now, if you find the value of R is close to 1, if you find the value of R is close to 1, that's an indication of strong linear correlation. Clear, Nakina? Yes?
Yes, sir.
Okay. So for example, in case of 1, if I find the R to be 0.94, let's say, and if in case of 3, if I find that R to be 0.6, which one is stronger correlation now? Which one exhibits stronger correlation? The one in graph 1, right, Nakina? Yes?
Yes, sir.
Okay. Is it clear to everybody? Did you understand this one, Nakina?
Yes, sir.
Okay. Awesome. So we can find, using the Pearson's correlation coefficient formula, the value of this R. Okay. Awesome. Now, if you find the value of R to be close to -1, what does that indicate? It indicates that the relationship, the correlation between the two variables is strongly okay, strong linear correlation, should not strong positive linear correlation, right, Nakina? Yes? Okay, positive. Acha. If you find it to be -1, that's also linear correlation, but it's strong negative linear correlation, right, Nakina? Yes, যত -1 এর কাছাকাছি হবে তত strong negative linear correlation. Clear, Nakina? Is that okay?
Yes, sir.
That's the interpretation of this, Pearson's correlation coefficient. And if the value of R is closer to 0, that means there is weak linear correlation or almost no linear correlation exists. Okay, weak linear correlation, maybe there is no linear correlation between the two variables. Is it okay, Nakina? Clear? Are we good?
Yes, sir.
Yeah. So I can use something called the Pearson's coefficient to measure how strong is the correlation between two variables. I can do that. Is it clear, Nakina? Are we good? Yes. ঠিক আছে so far?
Yes.
Okay. Now, what is the formula for this PMCC or product moment correlation coefficient? Now, that I'm going to ignore because this is something you're supposed to know from statistics. In case you're interested, just Google search, how do you find Pearson's correlation coefficient? I'm sure you'll get some formulas and you can look it up. But right now, we're not interested in the formulas, okay? We're interested more in the interpretation of that. So are we good so far? Everyone's good? Acha. Now, you might say, okay, sir, you said R is close to 1. Can R be exactly equal to 1 ever? Yes. R can also be exactly equal to 1. It may be very a rare case, but it could. Definitely it could. And I can show you some examples of that. Now, when will R be exactly 1? R would be exactly 1 when we draw the best fit line and all the points lie on that line. If that's exactly like that, there is no hither and thither a little bit, okay, everything falls on that line, then R is +1, exactly +1. That's the strongest positive linear correlation, right, Nakina? Did you get that? Yeah. Similarly, when R is exactly equal to -1, that means when you drew this best fit line, all the points, all the data points lie exactly on that line, okay? That's the strongest negative linear correlation, which is -1. Clear, Nakina? Is that okay? Are we good? Hello. ঠিক আছে নাকি ঠিক নাই বলতে হবে? You guys are quiet. Not here. ঠিক আছে? Okay. So now we're gonna see how can you use the idea of Pearson's correlation. এই যে এতটুকু যেটা দেখালাম আমি ব্যাকগ্রাউন্ডটা, these are things that you are supposed to know from statistics course. But in any case, what I'm interested now is I am interested in finding the important features using this Pearson's correlation, and I'll tell you how do you find this one. The idea is extremely simple. What do I do? The idea is this. Look at this one. Now, let me show you the idea behind selecting features, okay? So say we have certain features. So the features are, let's say, x1, x2, up to xn. And let's say this is the target variable. So these are the features. Am I right, Nakina? Yes? Sir, is that okay that these are the features?
Yes, sir.
And this is the y, which is the target or class label, whatever you want to say, right? Okay. That is a target, no problem. Okay. Now, if it so happens that let us say that we have found out let's imagine we found that let's say we find the linear correlation between the features. মানে প্রত্যেকটা ফিচারের সাথে linear correlation কত, let's say we have found that. And let's imagine we just found that, okay, that let's take this as an example, okay. Let's say we found that x1 and x2, these are the two features we have, and we found that x1 and x2 has, let's imagine, a linear correlation, okay. Let's say we find the linear correlation between x1 and x2, and let's say the linear correlation between x1 and x2 comes out to be something like 0.96. So what can you say about the linear correlation between x1 and x2? Is it strong? Is it weak? Or what can you say? Strong. ঠিক আছে? So they are very strong. The relation between them is very strong. Clear, Nakina? Yes? Yeah? correlation between them is very strong. Can I say that, Nakina? Yeah.
Yes, sir.
Even if it is negative, let's say if it is minus 0.96, then also there is a strong correlation, but it's a negative strong correlation. But in either of the cases, they have x1 and x2 have what? Very strong correlation between them. Clear? Is that okay? Does it make sense?
Yes, sir.
If that is the case, then আমি যদি x1 use করি, do I need x2 as a feature? Because what I'm trying to find out is I'm trying to find out how is y is affected by all these features. Now, if I see x1 and x2 have a strong correlation between them, so x1 যেভাবে y কে affect করবে, x2 exactly same ভাবে y কে affect করবে, তাহলে দুটো রাখার কি কোনো দরকার আছে?
No, sir.
No. So they would be like redundant features. They would be like what? Redundant features. Redundant features means because their impact is the same. So দুটোকে রাখার কোনো দরকার নাই, যে কোনো একটা থাকলেই হবে. Am I clear নাকি না? So if you keep x1, then you can drop x2. And if you keep x2, then you can drop x1. Clear? দুটো রাখার কোনো দরকার নেই. It doesn't have any additional impact on y. Does it make sense, Nakina? Yes?
Yes, sir.
So that's the very idea we are going to use to actually find the important features. That means other features that are redundant, okay? I can remove those redundant features using this very idea. So that's basically our strategy over here. So let's go back here. So what is the idea? The idea is highly correlated features with target variables are important features, sure, but high correlation between the features, say over 90% or over 80%, so you can decide on your threshold. They indicate the existence of duplicate, or I would say redundant features. Is it clear, Nakina? In case of these redundant features, we do not need to take all these features, but one of them would be enough. Is that right, Nakina? Is that making sense? ঠিক আছে? Hello?
Yes, sir.
Yes.
Yeah. So that's the idea we are going to run. So what I'm going to do now is I'm going to use, a data set called absenteeism. So let's read that data set. So this data set, these are all available in your Google Classroom. But let's just read the data set. Okay, read the Excel file called absenteeism.xls. Print out the shape of it, so I know the dimension of this data set, and also let's say we see the first 5 instances of this data set. So we can see here we have a lot of things here. Okay, so these are 740 rows and 21 columns. Now what are these 21 columns that we have? We have something called ID, we have something called reason for absence. তার মানে এটা হচ্ছে কোন একটা অর্গানাইজেশনে employees were absent and they were actually writing out a lot of things about his absence details and other things like reason for absence, কোন month absence ছিল, কোন date absence ছিল, কোন season ছিল, how much was his transportation expense, distance from residence to work, কত service time কতক্ষণ, age কেমন, ঠিক আছে, lots of things, disciplinary failure ছিল নাকি, education level কি, তার কয়টা ছেলে মেয়ে আছে, ঠিক আছে, is he a social drinker, social smoker, pet আছে নাকি, weight কত, height কত, body mass index কত, they measured it and they also figured out what's the absenteeism time in hours, ঠিক আছে, so that's they have. Okay, all right, so we'll see what we can do with that. Okay, so first thing, df.drop-in. Drop-in মানে কি করি, if there is any
Now,
null variables, we can get rid of that, ঠিক আছে, in place equals true, and df.shape. So there were quite a lot of that, 740 instances, 639 instances চলে আসলো. Then let's print out the columns. If I print out the columns, you'll see the absenteeism time in hours. This is our y. This is something we would like to predict. And Nakina, this is not a feature. This is like y. Correct, Nakina? Is that clear? Yes. So let's separate the x and the y. So in order to separate the x and the y, what we have done over here, let's see over here, where are we? In order to, where am I? Yeah, separate x and y. Yeah. So y is df absenteeism time in hours, x is df.drop, columns is absenteeism time in hours. So এখানে absenteeism time in hours সেটা হচ্ছে feature না, that's the target, so I'm going to separate it out. That's y and the rest of them are x. Am I clear, Nakana? Is that okay? Does it make sense? Yeah?
yes, sir.
Okay, so x dot head করলে you'll see that I do not have this absenteeism time in hours anymore. ঠিক আছে? So these are all the features. So x dot head, that absenteeism time in hours is not there. Y dot head, it only includes absenteeism time in hours, as you can see over here. Right, Nakina? Yes? So we have x and y there. Now, what I'm going to next do is, before you do any kind of feature selection, so feature selection is it's a data pre-processing task as well. Now, do we apply this feature selection on test set as well? Like, only on the train set?
So only 10 set.
Only on the train set. We do not do it on the test set. So feature selection algorithm ta chalabo na on the test set. I should always apply this on the train set, right? It's because test set should be used only for what? It should be used only for
Evaluation or
testing. That's it. We do not use it for model creation. Clear, Nakina? Is that okay? So because I'm not going to use the test set to actually, apply this, find this Pearson's correlation, let's actually split the data set into trained and test set. Okay, so that's the next thing that we have done. So you see over here, sklearn.model selection থেকে we have imported in train test split, and then drop করছি id drop করছি because id is a personal identifier, so এটার কোনো কাজ নাই, ঠিক আছে? Then after we're dropping the id, let's do the train test split with the test size of 0.2. We are splitting x and y. When we have done that, we're done with the splitting. ঠিক আছে নাকি না? Clear? Okay, are we good? Yes. So we have now a test set and a train set. ঠিক আছে? Okay, so let's import some interesting libraries, like I'm importing the matplotlib.pyplot. Okay, if we do that, let's see this one. So we imported this. Now this is very important. What we have in xtrain এ কি আছে বলতে পারেন? আচ্ছা, let's go up here and I'll just write on x_train.head. xtrain এ কি আছে বলতে পারবেন? What we have in xtrain?
স্যার ট্রেন করার জন্য যেই ডাটা সেট
The features only, the features for the train set, right? So if you see that these are the features for the train set. So the first 5 instances are the 645 number row index, 588 row index, and so on, right? Okay, so this is a train set on which you can be applying. Now, I can run a Pearson's correlation with only one line of code, and the code is this. I'm going to find out the Pearson's correlation between all these features. প্রত্যেকটা ফিচারের সাথে প্রত্যেকটা ফিচারের কোরিলেশন কত, রাইট নাকি না? Yeah, that's what we would like to find out. So all you have to write is xtrain থেকে নিচ্ছি, xtrain এ যেই ফিচার্স গুলো আছে সেগুলোর এক একটা ফিচারের মধ্যে কোরিলেশন কি, that's what we want to find out. All you have to write is xtrain.core. That's it, done. It will find out the feature, a correlation coefficient between all the features that we have in xtrain. Is it clear, Nakela? Yes?
Yes, sir.
Yes,
Okay. All right. And a slight note, but this is something that you know, that the correlation lies between -1 and +1. A correlation value close to -1 indicates a strong negative linear correlation. A correlation value close to +1 indicates a strong positive linear correlation. And a correlation value of 0 indicates no linear correlation, right? We know that. We have already spoke about that. Now, because you found that the correlation between each of these features, between all these features, let's see how does it look like. So I printed a core. So if I do that, so you see the প্রত্যেকটা ফিচারের সাথে প্রত্যেকটা ফিচারের correlation কেমন. Reason for absence against month of absence, correlation is negative. Okay, it's almost 0. ঠিক আছে? It's minus, I know, but minus 0.08, that's almost 0. There's almost no correlation, right? নাকি না? Yeah. So কোনটার সাথে কি এখানে মধ্যে দেখেন, reason for absence against reason for absence is how much? 1. Why is it 1? Because it's the same data you're using. Reason for absence or reason for absence. So when you plot the graph, so it must fall on the best fit line যেটা draw করবেন, all the points would be on the best fit line. That's why it's +1. ঠিক আছে, right নাকি না? So month of absence against month of absence, that should be +1, right? So can you see that we have found out the correlation between all these features, right নাকি না? Can you see that নাকি না? Yes? Hello? Can you see that?
Yes, sir.
প্রত্যেকটা ফিচারের সাথে but these are all numbers between -1 and +1. I think it's a good idea not to show it like this way. It's a good idea in order to draw a very nice diagram for the heat map. So what do you do? How do you draw a heat map? Heat map is a very good way to visualize correlation in using correlation between features. So in order to draw a heat map, what I've done over here, I've done plt.figure, and so I'm going to draw a figure. So I've given a figure size, and then I'm going to write SNS, Seaborn's SNS, right? Dot heat map. I'm providing that cor, which includes all the correlation between the variables. So I'm going to take this, and I'm going to say annotate equals to true. This will annotate the values in my heat map. And I'm also selecting a CMAP. CMAP is selected as, CMAP means color map. This is seismic. Now, if you want to use a different CMAP, well, there's a very interesting site over here. I would advise you to go to that particular site. So let me just show you very quickly. And you'll see over here, there's a lot of color maps. You have a lot of names, so you can select any of them you like. You'll just see different diagram is shaded different diagram, the different looking hub. But I just selected seismic right now. Okay, so if I do so, what would happen? Now let's see. If I do that, it's going to take a little bit of time, but it generated a heat map. Now, this is a very interesting heat map. Why do I like this heat map? There is a reason why do I like this heat map. See, first of all, you see, I have got all the features here. This is a two-dimensional diagram, so features on the y-axis and the same features on the x-axis. And then what it shows me is the correlation between everything. So for example, age and what is this one? This is probably reason for absence, and that is 0.04, I guess. So if you see over here, age is right? Minus minus 0.04. Okay, I couldn't see the minus. Okay, anyway, this was age yes, minus is there, 0.04. Age car correlation, এটা হচ্ছে reason for absence. প্রত্যেকটার সাথে প্রত্যেকটা correlation এভাবে draw করা আছে। কিন্তু what's so interesting in this heat map? এইটা diagram যখন করেছে, we have given some shades over here. যত correlation তোমার হচ্ছে 1 এর কাছাকাছি যাচ্ছে, তত it's getting more and more reddish. Can you see that নাকি না? Yes, can you see that?
Yes, sir.
Yeah, and when it's absolutely dark red, this is very +1. So all these diagonals are +1. Why are all these diagonals +1? Because these are reason for absence against reason for absence, month of absence against month of absence. So it's the same data against same data. So this should be +1. Okay. So we actually have this interesting way of showing that. There is one interesting thing that I want to show you over here, and this is very easy to see. Eta kisher against kisher reason for absence against eta ki. What's the second one over here? So if you come down over here, second one to month of absence, right? Yeah. So this one that you have, this cell, this is showing minus 0.082, is reason for absence against month of absence. Abar ekhane dekhen month of absence against reason for absence should be the same. তাই না নাকি না? এর সাথে b এর correlation আর b এর সাথে এর correlation একই হবে, right? নাকি না? Yes.
Yes,
Hello. So you see যে এখানে diagonal ধরে যদি একটা triangle চিন্তা করেন, okay, এই diagonal ধরে যদি একটা triangle চিন্তা করেন, so the lower triangle is a reflection of the upper triangle. Lower triangle and upper triangle, these are like reflection of each other. Minus 0.043, minus 0.043, minus 0.14, minus 0.14. Can you see that নাকি না? Yes. 0.048, 0.048. একটু উপরে যায় 0.138, একটু এদিকে যায় 0.13, minus 0.19 আর এদিকে plus 0.19. Can you see that নাকি না? Yes. Okay.
Yes, sir.
So আমার পুরো তাহলে দরকার নেই। So আমি either I can keep the lower triangle or I can keep the upper triangle. Is it clear নাকি না? Yes.
Yes, sir.
ঠিক আছে। Now এই যে heat map যেটা আছে, এই যে heat map যেটা draw করেছি, this has an interesting parameter. So let me show you the parameter here. So if I come over here, there's a very interesting parameter. So the ones that we use the anode true correlation, and we also have given this data which is correlation. ঠিক আছে, আরেকটা কি করেছেন, আরেকটা করেছেন হচ্ছে CMAP দিয়েছিলাম, which is seismic. So you can do all these things. Now there is a very interesting parameters over here, which is actually called mask বলে একটা প্যারামিটার আছে। I'll tell you what does this mask do. So if we go down in this documentation, It's written what each of these parameters gives you. Mask. Mask is a Boolean array or a data frame. It's an optional parameter. If you pass the mask value, data will not be shown in the cells where the mask is true. So mask value is a Boolean value, it's either true or false. ঠিক আছে? যেসব জায়গায় mask value true থাকবে সেই সব জায়গার ইয়েগুলা দেখাবে না। ঠিক আছে? সেলস গুলা দেখাবে না। তাহলে যদি আমি এমন করতে পারি যে সবকটা উপরের গুলা মাস্ক যদি ট্রু করে ফেলি তাহলে শুধুমাত্র লোয়ার ট্রায়াঙ্গেলটা দেখবো, অথবা সবকটা লোয়ার ট্রায়াঙ্গেল গুলা যদি ট্রু করে ফেলি মাস্ক ভ্যালু তাহলে শুধুমাত্র আপার ট্রায়াঙ্গেলটা দেখবো। ইজ ইট ক্লিয়ার নাকি না? ইয়েস, ডিড ইউ আন্ডারস্ট্যান্ড দ্যাট নাকি না? ঠিক আছে? Okay,
Yes.
so we can do that as well. So let me show you how to do that. It's very easy to do this. So you import something called numpy first of all, and numpy.try u. This means upper triangle. Upper triangle গুলা 1 করে ফেলছে। Upper triangle 1 করা মানে কি? তার মানে 1 মানে ট্রু। সো এইটা হচ্ছে np.upper triangle গুলা 1 করলে তাহলে আপার ট্রায়াঙ্গেলটা হচ্ছে ট্রু। আর এখানে np.trial, that means lower triangle গুলোকে 1 করে ফেলছি, that means ট্রু করে ফেলছি। I can do that. So আমি যদি mask 2 টা নেই, এই যে দেখেন again the same heat map, correlation annotate equals to true, cmap equals to seismic, and now I'm giving a different mask value. Let's say mask equals to 2. What will happen? Mask 2 মানে কি? লোয়ার ট্রায়াঙ্গেলটাকে কি করেছি? এই যে মাস্ক 2 হচ্ছে লোয়ার ট্রায়াঙ্গেল গুলা 1, ঠিক আছে? লোয়ার ট্রায়াঙ্গেল গুলা যদি 1 হয় তার মানে লোয়ার ট্রায়াঙ্গেল গুলা যেগুলো 1 আছে সেগুলো দেখাবে না। সো I just see the upper triangle now. Can you see that নাকি না? Yes, did you see that? So I can use this simple interesting thing to do that. আমি তুমি যদি চাও না আমি এই লোয়ার ট্রায়াঙ্গেল দেখতে চাই, আপার ট্রায়াঙ্গেল দেখতে চাই না, তাহলে আপার ট্রায়াঙ্গেল সব 1 করতে হবে, which is done by this mask 1. So all you have to do is to select mask 1 and then run that, and that's it. So you see the lower triangle only. Clear nahi na? Because they're same thing, so it's no point of seeing the entire thing. So you can become much more clearer diagram like this way. Is it okay? Are we good nahi na? So far so good?
Yes,
Hello.
sir.
Yeah. Okay, so now another thing I'm just quickly want to show you that এই যে এখানে আমি যে কি বলে cmap seismic use করেছি। You might say seismic না use করে কি অন্য কিছু use করতে পারতো না? Yes, you can choose anything you like. So আমি randomly একটা choose করে দেখি। Let me choose turbo. I don't know, I never used that one. Turbo, let's see. So if I use turbo instead of seismic, what would happen? So I just go over there and I write turbo, run that. Okay, just a minute. So now you see a different color diagrams. So the color map, CMap is now different. ঠিক আছে? Okay, so you can play with this one, find out ones that is interesting to you. The seismic dilam, seismic, that's the one. So you can play with this one, try different things, see which one looks nicer. You can use that one. ঠিক আছে? Okay, so that's just for this color map. Is it clear so far, Nakina? Yeah. Okay, so far what we have is I now have the correlation between features. প্রত্যেকটা correlation between features আছে। But আমার কাজ কি? আমার কাজ হচ্ছে I want to drop the redundant features. How do I do that? Now I've written a very small function over here এবং এই ফাংশনটা খুব simple. Just understand the function. So I'm writing a function, so it's def. The name of the function is correlation. You could give it any other name you like. So let's call it correlation. And it's going to take two things. It's going to take a data set, let's say, data set of features only, and it's going to take a threshold value. ঠিক আছে? I'll tell you what it does. ঠিক আছে? আমার কাজ কি? আমার কাজ হচ্ছে এই যে remember this one, যে দুটো ফিচার যদি খুব strongly positively correlated বা strongly negatively correlated হয় তাহলে একটা থাকলেই হবে, আরেকটা দরকার নেই, right নাকি না? Do you remember this? Yes?
Yes, sir.
Okay, so what I'm going to do is I'm going to run a for loop. It's a 2-dimensional for loop. So প্রত্যেকটার সাথে প্রত্যেকটা correlation চেক করব। চেক করে দেখব এটা কি এই থ্রেশহোল্ড যে ভ্যালুটা দিয়েছি কোরিলেশনে, এই থ্রেশহোল্ড ভ্যালু থেকে বড় বেশি নাকি। যদি বেশি হয় তার মানে হচ্ছে ওই দুটো ফিচার্স হচ্ছে রিডান্ডেন্ট ফিচার্স, তাহলে একটাকে রাখবো আরেকটাকে বাদ দিব। Am I clear নাকি না? Is that okay? Is that idea all right?
Yes, sir.
Yeah, so that's exactly what I'm doing. So look at this one. First of all, I'm actually having a let's say we have a parameter here, okay, column correlation, equals to set. So I'm taking a set. So this is really a set. So I hope you know what's a set. Set is a data structure, right? So I'm taking a set, okay, here. Are we good, Nakina? Yes? Okay. So first of all, ওই যে data set টা যেটা দেওয়া হয়েছে, এই data set এর প্রত্যেকটা ফিচারের সাথে প্রত্যেকটা ফিচার correlation বের। So dataset.core is a correlation. ওই correlation matrix থেকে store করলাম in this core matrix or correlation matrix. Now I'm going to run through this correlation matrix. So I have to use two for loops, nested for loops, because it's a two-dimensional matrix. So I'm going to apply two for loops for I in range of the length of the correlation matrix or columns and for j in range I. ঠিক আছে? So প্রত্যেকটা correlation check করছি। এখন কিভাবে চেক করছি? যদি কোনোটা correlation matrix between I and j features যদি greater than threshold হয়, তাহলে কি I and j দুটোকেই রাখবো নাকি যে কোনো একটাকে রাখলে হবে? যে কোনো একটাকে রাখলে হবে। আচ্ছা, যেটাকে রাখতে চাই না, so it's up to you, তুমি I কে রাখতে চাও না অথবা j কে। let's say first টাকে আমি বাদ দিতে চাই, I যেটাকে বাদ দিতে চাই আমি বাদ দিব না। I'm going to take that particular column I and I'm going to store that in what so that's the particular column, and I'm going to add that particular column in that particular set that I have. Is that clear, Nakina? So it's going to run a loop and loop and loop, and then once we are done with the loop, then that particular set will contain all the redundant features. Am I correct, Nakina? Yes? ঠিক আছে? যখনই threshold value বেশি তখন তার মধ্যে একটাকে ওই পার্টিকুলার ইয়েতে সেটে রেখে দিচ্ছে। না, একটা জিনিস খেয়াল রাখবেন, I have taken absolute value of the correlation, কারণ strong negative correlation ও কিন্তু strong correlation, right? ওটাও চেক করতে পারেন, that's why absolute value here. Okay, so what this will do is when you run this particular function, it's going to return you a set of columns which are redundant and you can drop them. So let me run this code. Okay, so this is just a function, the function ran. So now I'm going to use this function. So let's say আমার যে ইয়েটা ছিল, data set ছিল, সেই data set হচ্ছে xtrain থেকে নিচ্ছি। So I'm going to call this function called correlation. The function name is correlation. And I'm going to supply two things, the data set, but I'm going to give the xtrain, the features only. And let's say 0.9 gram as the threshold correlation. 0.9 এর উপর is a very strong correlation. Now, এটা যে 0.9 রাখতে হবে তা কিন্তু না। You can keep it 0.9, 0.8, 0.85. Don't take it below 0.8. ঠিক আছে? Okay? So 0.8 পর্যন্ত থেকে রাখতে পারো, but 0.8 এর নিচে নামিও না। But I kept it at 0.9. ঠিক আছে? So when I did that, so 0.9 এর থেকে বড় যেগুলো সেগুলো এখানে অ্যাড করে ওই পার্টিকুলার সেটটাকে রিটার্ন করবে। সো এই সেটটাকে যে রিটার্ন করছে, আই এম স্টোরিং দ্যাট columns in this particular set called correlation feature. So then I printed out the length of this particular set, so it's saying that how many redundant features did we get, and we also print out the correlated features. So if we just run this one, oh well, you see I found only one particular parameter or one particular feature that I can drop, which is body mass index. Now if you look at this carefully, body mass index দেখেন তো পরে এই যে body mass index যেতে থাকেন body mass index, ঠিক আছে? দেখবেন যে এই যে ওয়েটের সাথে কত ছিল স্যার, 0.9 দেখছেন? So body mass index with weight has a very strong positive correlation, তাহলে একটাকে রাখলেই হবে, এবং this particular function has actually identified body mass index as a redundant feature, which is great. So I can just drop body mass index. ঠিক আছে? So then I can drop this body mass index from both xtrain and xtest. Am I clear, Nakina? Is that okay?
Yes, sir.
That's a simple thing that I can do, right, Nakina? Okay, so this is something very useful. There are other algorithms as well. So how do you find out features using information gain? Then there's something called recursive feature elimination. I think I'll just not look at it right now. ঠিক আছে? I'm happy as long as you understand how can I actually use this Pearson's correlation to identify what are the redundant features we have. ঠিক আছে? Okay, so I hope that's clear, right, Nakina? Yes, clear to everybody?
Yes, sir.
Okay, thank you very much. So let's see, I'll save it. Acha, okay, let's go over here. Let me very quickly show you another interesting example so that you are very clear about what's going on here. So if you go to Anaconda prompt, E drive, let's switch to E drive, ML, teaching, CD note, books. Okay, let's see. Okay, so we were actually, I was working with one of my students was working with me on a project called premature beats. So it finds out premature heartbeats and things like that. I'm going to quickly show you how interesting this was. Okay, so if we go to okay, so let's just open the Jupyter notebook right there. That see what happens now. Okay, so I'm not going to do anything interesting and new here. I'm going to simply show you very quickly what happens here. It's going to take a little bit long time, but because there's a lot of things here. Okay. Anyway, hote thaku, but let me go ahead from the beginning. So we imported the libraries. We are reading a data set. এবং এই data set থেকে যেখানে আমি হেডটা প্রিন্ট করছি তুমি দেখতে পাচ্ছ অনেক কিছু আছে। ওকে, জেন্ডার, এজ, বিএমআই, স্মোকিং, স্মোক করে কি করে না, অ্যালকোহল লেভেল, ক্যাফিন লেভেল, হাইপারটেনশন আছে কি না, ডায়াবেটিস আছে কি না, blah 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 blah, so many things. And finally we figure out whether this person has any record of symptoms or not. That means premature heartbeat problem issues are again. Okay, then of course we do the initial pre-processing things. If there is any duplicates, we drop the duplicates, and in fact to our surprise we found there's a lot of duplicates. 628 instances, 601, so 27 entry rows were deleted, so there were so many duplicates. We got that. Is null.sum, so there were a lot of values missing entries. So then we did a couple of things there to actually handle that. So we will not go to that one, what we have done. So we've handled these things. We renamed the columns, we renamed the we did a couple of more interesting things. Okay, so we're not going to that one. What I'm interested to show you is here. So these are I think we were doing feature scalings and stuff like that. Yeah, so sorry, here is where we're doing feature scaling. So that's not, don't worry about that. What I'm interested is to show you feature selection. First, feature selection, we applied something called zero variance features. We try to find a zero variance feature. So instead of, so we just wrote a code. So zero variance feature নামে একটা লিস্ট তৈরি করলাম, which is an empty list, and xtrain.columns এর মধ্যে we are seeing the unique values কতগুলো আছে। unique values যদি length 1 হয়, যদি একটা unique value থাকে, that's a zero variance feature, so we append that one. Now interestingly we found magnesium n বলে একটা ইয়ে আছে, that's a zero variance feature, so we do not need that, so we dropped it from the train set as well as the test set. Clear নাকি না? Okay, so we applied, so feature selection was useful, so magnesium n. And now we have, look at this one, 256 rows and 72 columns. Okay, fine. Now then we wanted to use these correlation coefficients. So xtrain.core, so we saved it in this core, and then okay, this is a seriously because there's just so many columns, that's why this looks so dense. Okay, then we apply that function that we have to find out correlations, okay? And then here 0.8 tracks it, that's a threshold. 0.8 এর বেশি রাখলে it will figure out the 0.8 এর বেশি যেগুলো correlation আছে তার মধ্যে redundant features গুলোকে return করবে. And when we printed this off, do you see how useful it was? How many redundant features we've got? 26 redundant features, and we can simply drop all the 26 redundant features. So you see, before dropping redundant features, we have 72 columns, but after dropping the redundant features, we came up to 46 columns. So now you can see how effective these feature selection algorithms are. Is it clear, Nakina? Yes? Can you see that?
Yes, sir.
So it's a very useful feature. So we have discussed that. That's it. So that's just to show you that how useful these features are. Okay. Now, all right, moving quickly. Okay, we want to discuss some more things today. Okay. All right, let's go there. Okay. Okay, quickly over here. Now, we wanted to discuss something called imbalanced class issues. So someone was saying that somebody has a very imbalanced class, and what we do in the imbalanced class problem. ঠিক আছে? Imbalanced class যদি থাকে, how do you deal with this imbalanced class? ঠিক আছে? Okay. Now we do not have much time, unfortunately. I think we have about 20 minutes, so let's see how far we can go. ঠিক আছে? Now, it is not uncommon to have imbalanced class, okay, data set. Now, lots of classification problems exist, okay. There are a lot of classification problems, okay, where the classes are very, very skewed. একটা particular class level অনেক বেশি আর একটা class level খুবই কম, ঠিক আছে? Examples include credit card fraud. Credit card fraud, that's a interesting example. It's because, you know, যত ক্রেডিট কার্ড ট্রানজাকশন হচ্ছে ফ্রড ট্রানজাকশন কিন্তু রিলেটিভলি কম হবে, that is the one you will not get too much, you know, records of, but that's the interesting thing that you'd like to detect, right, Nakina? So if you're looking credit card transaction, fraudulent credit card transaction, a particular records গুলো খুব কম হবে. So those sort of data set would be highly imbalanced, right, Nakina? Yes, yeah, ঠিক আছে নাকি না? Yes. আরে স্যার আপনারা কোথায় হারায় যান?
Yes, sir.
Yes, sir.
Okay, right. So now you may have class imbalance issues, okay. So let's say you have a data set in Y, so we are interested in Y. So you have got Y তে দুটো জিনিস হতে পারে. Let's say you have A and B. So let's say this is A and B. These are the two things you can have. Now এমন যদি হয় 50% A, let's say A and B, এমন যদি হয় 50% of the classes are A and 50% of them are B, then is it imbalance or balanced data set?
ব্যালেন্সার।
Balance. What about this is well 50% না বলতে একদম ইয়া দিই, ধরো 500. So what about this now? Balanced data set, right? So let's say A তে 400 আছে আর B তে 600 আছে. What about this one?
Imbalance.
No, that's still balanced, not imbalanced really. ঠিক আছে, that's still balanced. সব সময় যে exactly 50% পাবেন তা তো না, তাই না? Even 300 700 can be considered as balanced. But যদি 200 800 হয়ে যায়, that's where you're going towards imbalance. Clear নাকি না? Is that okay নাকি না? ঠিক আছে? Okay.
Yes.
So don't get frustrated if you're saying you have got 350 and there you have got 650. That's also fairly balanced. ঠিক আছে? Exactly 50% কখনোই পাবেন না, right? নাকি না? Yeah. So when you see that the ratio between them or the difference between them is too high, then you have a class imbalance issues. ঠিক আছে? And this class imbalance issues needs to be tackled and needs to be seen how to do that. ঠিক আছে? Okay. All right. So what is the problem? So far, you know, when we actually evaluated how well our model is working, we use accuracy as a way to measure. Kind of accuracy to measure. I saw we did this. My test accuracy is this much, and my train accuracy is this much. Yes, nakina. So far, whenever we have evaluated a model, it turns out when you have a class imbalance problem, accuracy is not a very good metric to measure the performance of a model. ঠিক আছে? Okay, so evaluation measures such as accuracy are not well suited for imbalanced classes. It's pretty fine with balanced classes. ঠিক আছে? এইগুলো হচ্ছে all balanced classes. These are fine with those, but for imbalanced classes, accuracy is not a very good metric. And I'll tell you why accuracy is not a good metric. First of all, we'll understand that, and then we'll see what are the different alternatives we have. Okay. So remember confusion matrix? All of you remember confusion matrix? Nakina?
Yes, sir.
Okay. So here, let's say we have a class. It's a binary class, so yes or no. So we draw a confusion matrix, which is a 2x2 matrix, right? Nakina? Okay. So actual class yes, actual class value is no. A predicted class value is yes, predicted class value is no. তাহলে এখানে A এটা কি? Actual class yes and predicted class yes. So what is this? Isn't it true positive?
True positive.
True
আচ্ছা।
positive.
আর এখানে দেখেন actual class no and predicted class no. That means predicted class correctly has identified that this is no, so it's true negative, right? নাকি না?
Yes, sir.
What about this one? B টা কি হবে?
false positive.
ওকে ওয়াই ফলস পজিটিভ দেখি
আর
অ্যাকচুয়াল ক্লাস হচ্ছে
actual-
ইয়েস অ্যাকচুয়াল ক্লাস হচ্ছে ইয়েস দেখি অ্যাকচুয়াল ক্লাস হচ্ছে ইয়েস বাট ইউ প্রেডিক্টেড ইট অ্যাজ নো so prediction is wrong right nakina but you predicted it to be no so it's false negative you incorrectly predicted it to be no it's not negative but you actually predicted it to be negative so that's called false negative correct nakina
Yes, sir.
and see over here actually it is no but your model has predicted it to be yes so model predicted it wrong but it falsely predicted it to be positive so it's a false positive one ঠিক আছে is it clear নাকি না ঠিক আছে
Yes, sir.
Okay.
are we good okay fine so yeah so we know that so if we want to find out accuracy that's the one that we were measuring so far accuracy মানে কি accuracy মানে হচ্ছে correctly কতটা classify করেছি right নাকি না so we have altogether A, B, C, and D, these many instances, right? Nakina. So total number of instances are A plus B plus C plus D. That means TP plus FN plus FP plus TN. If you add them up, that's the total number of instances. Out of this total number of instances, these true positive and true negative are the correctly classified instances. Then Nakina. Ekhane actual and model predictions were correct, right? Nakina. Yes? ঠিক আছে?
Yes, sir.
Yes,
So
sir.
out of the entire, which is A plus B plus C plus D, okay, out of A plus B plus C plus D, you are correct in A plus D. A plus D, that many correct instances you have. So the accuracy is A plus D divided by the entire thing A plus B plus C plus D, or it's TP plus TN, true positive plus true negative. These are the correctly ones over the total number of instances you have. Is that okay, Nakina? Yeah. So that's how we measure accuracy. Is that okay to everybody?
Yes, sir.
Okay. Now, what we have said initially is that for a imbalanced class, accuracy is not a good metric. I'll tell you now why accuracy is not a good metric for an imbalanced class. So we'll talk about what's the problem with this accuracy metric now. Now consider we have a two-class problem. So we have got two-class problem, okay? And the number of no examples, there are 990 no examples, and there are only 10 instances with yes examples. So this is definitely an imbalanced class. Like that, দুইটা ক্লাস হতে পারে yes or no, yes এ 10টা আছে আর no তে আছে 990টা. So total how many samples are there? We have a total of 1000 records, right? Out of 1000 records, 990s are no and only 10 of them are yes. Is it right, Nakina? Yes?
Yes, sir.
Okay. So this is definitely there is a class imbalance here. Now, what is the problem if we are using accuracy as a way of measuring the model that you prepare? Okay, what is the problem? Let's say I create a model. So let's say I create a model. If I create a model that predicts everything to be class no. That means it's like a 0R classifier. তাই না মনে আছে 0R classifier যেটা মেজরিটি ক্লাস সেটাকে সে প্রেডিক্ট করে সবসময় yes নাকি না
Yes, sir.
so imagine we run a 0R classifier that predicts everything to be no so if you predict everything to be no how much would be the accuracy now you have altogether 1000 samples everything প্রত্যেকটাকে no বললে তোমার এই যে 10টা yes আছে এগুলোকে কি ইনকারেক্টলি প্রেডিক্ট করবে রাইট নাকি না yes
Yes,
কারণ
sir.
সবকটা কি সে নো বলছে তাহলে এই 10টা যেটা অ্যাকচুয়ালি ইয়েস সেগুলো সে নো বলবে সো দে উড বি ইনকারেক্টলি প্রেডিক্টেড রাইট নাকি না ইয়েস
Yes, sir.
Yes.
এবং বাকি 990টা কি হবে যেগুলো নো ছিল সেগুলোকে তো নোই প্রেডিক্ট করছে সো দিস আর কারেক্টলি প্রেডিক্টেড সো আউট অফ 1000 স্যাম্পলস how many of these samples were correctly predicted how many of the samples were sir আপনারা কি বুঝতে
Nine-
একটাও
পারছেন
করে নাই স্যার
আরে কি বলে ধুর
990.
990 yes come on how can you not understand this come on this is not good look there are 1000 samples okay out of the 1,000 samples, I am saying 990 are no, okay, and only 10 of them are yes. Yes, this is the actual condition. ঠিক আছে নাকি না? Actual picture. Now you're creating a classifier, or you're using a classifier, let's say 0R classifier. 0R classifier will predict everything to belong to that যেটার মেজরিটি ক্লাস সেটাকেই প্রেডিক্ট করবে। এখানে নো আর ইয়েস কোনটা মেজরিটি ক্লাস বলেন?
No.
No. তাহলে it will take this 1,000 samples when you train them, so সে এই 990 গুলাকে কি প্রেডিক্ট করবে? নোই প্রেডিক্ট করবে, রাইট নাকি না? আর এই 10টা যেটা আছে ইয়েস সেগুলোকে কি প্রেডিক্ট করবে? ওটাকেও নো প্রেডিক্ট করবে। আমি কারেক্ট নাকি না? That's what the 0R do, because 0R would predict everything to belong to the majority class, which is no in this case. So it will take all the sample and it will predict everything to be no. Correct নাকি না?
Yes, sir.
Yes, sir.
Yes. So now what would happen? You see, in reality, if you see a 990, এত সময় যদি লাগে এটা বুঝতে, a 990 of them were correctly classified, right? নাকি না? Actually no ছিল, the model has also predicted it to be no, right? নাকি না? But the problem is here. Look at this one. The problem is here. 10 of them are yeses, and it predicted them to be no. Correct নাকি না? So these were incorrect. Yes নাকি না? Yes, incorrect prediction was made here. Actually it was yes, but it predicted them to be no. Correct নাকি না? Clear?
Yes, sir.
Yes, sir.
So how much is the accuracy? That's what I'm saying. So out of 1,000 sample, it predicted 990 of them correctly. Right নাকি না? Yes. The rest of the 10 were not predicted correctly. Clear? নাকি এখনো বুঝেন নাই? Did you understand this or did you not understand this?
Yes, sir.
Yes, sir. বুঝছি।
Okay, so let's say if I look at it more carefully, okay, if I draw a confusion matrix here, okay, look at this predicted class, he can like actual class, he can like. So look at this predicted class and actual class. Zero are predicted class, predicted that this is a 0R classifier use করছি, okay. আমার yes predict করতে পারি, no predict করতে পারি, আর এটা হচ্ছে actual, ঠিক আছে, which could be yes or no. আচ্ছা এখন দেখেন 990s are no, actually no, yes, and it predicted all this 990 as no as well. তাহলে এটা কি?
The true negative.
990 instances are no and 990 instances were correctly predicted to be no. So what is that? That's a true negative, right?
True.
নাকি না? So true negative, there were 990 samples. Correct নাকি না? Yes? ঠিক আছে?
Yes, sir.
Okay. 10 of them are actually yes, but the model predicted to be no. So actually it's yes. Oh, sorry. Why did I put it there? Just a minute. Okay. I put it in the wrong place. Okay. So if you see over here, coming back, 990s are no and 990s are no. So actually no, and the model predicted to be no as well. So these are the 990 samples. 10 of them are actually yes, but the model predicted to be no. Actually yes, the model predicted to be no is 10 of them. Correct নাকি না? Okay. And there is no sample যেখানে actually yes and the model also predicted yes, because the model never predicted to be yes, and this is also zero. Clear? This is the confusion matrix. Am I clear নাকি না? Yes.
Yes, sir.
So if you see the accuracy was what? Accuracy was true positive plus true negative divided by everything, sum of everything, which is 1,000 samples. So true positive plus true negative, which is 0 plus 990, which is 990 divided by 1,000. So can you see that the accuracy is 0.99 or 99%? Yes, Makina.
Yes, sir.
So that's what I'm saying. So you use a 0R classifier to show that the accuracy is 99%, right, Nakina? But the problem with this one is the minority class যেটা ছিল আমার এখানে, minority class একটা sample কেও correctly predict করবে, correct নাকি না? So it did not correctly predict any of these minority samples, yet it has an accuracy of 99%. So do you see what the problem is right now? So you're giving a bad meaning to what is accuracy right now. ঠিক আছে? Class imbalance problem হলে accuracy is not a very suitable metric, because using the accuracy you can just say, my model is 99% accurate, yet minority classes যতগুলো ছিল একটাকেও সে ঠিক মতো predict করতে পারতেছে না। ঠিক আছে, right নাকি না? So I hope you understand the problem with the minority class. Can you see that নাকি না? So the problem with the minority class is if you use just accuracy to measure the metric, that's not a useful metric. Yes or no? Are we clear?
Yes, sir.
Okay, so that would mean that we have to see something else. Like here is an example. I'm giving you two particular, so let's say we have two particular classifiers, classifier A and classifier B. Now, look at this one. In this classifier A, 990 samples are no, which is correctly predicted to be no. So they're actually no, and they're correctly classified as no. So 990. And 10 of them are actually yes, but it's incorrectly classified as no. And your model prediction accuracy would be 99%. তাই না নাকি না? 0 plus 990 divided by 1000. Correct নাকি না? Yes?
Yes, sir.
That is 99% হয়ে যাবে। ঠিক আছে? আচ্ছা। But look at a different classifier here. Let's say classifier B. And what it is interesting. দেখো, ভালো করে দেখো। Actually no, and correctly classified as no is 490 samples. Actually no, but incorrectly classified as yes, there are 500 samples like that. But look at these minority ones. Actually yes, and predicted it to be yes. This is a minority one. These 10 are correctly classified. তাই না? তাহলে মডেল বিটা কি মোর ইন্টারেস্টিং না? কারণ এটা যেটা মাইনরিটি ক্লাস সেটাকে ওয়েল ক্লাসিফাই করতে পারে। Yes নাকি না? মেজরিটি ক্লাস, yeah, there is some মানে inaccuracies, but minority class থেকে ওয়েল প্রেডিক্ট করতে পারছে। Isn't that more interesting? Yes নাকি না?
Yes, sir.
But if you find out the accuracy would be true positive plus true negative. That means 10 plus 490, which is 500, divided by all together, which is 1000. So the accuracy will come down to 50%. So here in model B, you can see that it works very good for the minority class, but the accuracy is lower. ঠিক আছে? But here it doesn't measure any of the minority classes. ঠিক আছে? But yet the accuracy is 99%. So you see, accuracy is not a reliable metric when it comes to imbalanced classes. Is that okay to everyone, Nakina?
Yes, sir.
Yeah. So that is the problem with this accuracy metric that we have. ঠিক আছে? So okay, so I leave it to you to decide on this one. What do you think? Which one do you think is better? So I think you have understood what's the problem with the accuracy metric. ঠিক আছে? আচ্ছা স্যার, আমাদের হাতে মনে হয় আজকে সময় নাই। ঠিক আছে? Unbelievable. ঠিক আছে? So what I'm going to do next class আমি একটু বলি, because now we have realized that accuracy is not a very good or very suitable metric when it comes to class imbalance issues. Okay, I'm going to use some more metrics, and these metrics are called precision, recall, F1 score. তারপর আরেকটা আছে আমরা দেখবো, it's called the area under the curve of rock. Area under the curve of a rock curve. There is a rock curve. Okay, so we're going to use a number of metrics to measure these sort of things. ঠিক আছে? Okay, for imbalanced classes. If it's exactly perfectly balanced, well, we will also keep accuracy. ঠিক আছে? এটাও মেজার করব, ওটাও মেজার করব, কিন্তু দেখা যাবে যে যদি এটা ব্যালেন্স ক্লাস হচ্ছে accuracy একটা is a reliable metric. You don't need to worry about others. But in reality, it's not always perfectly balanced. So you need to consider other metrics because they would help you to understand how the model has performed better. So these are called precision, recall, F measure, and area under the curve of a rock curve. We'll see in the next class. Because how do you measure all these sort of things actually and figure and that gives a better meaning to these particular class imbalance issues. Okay? We'll see that in the next class. But did you understand so far that you cannot rely only on the accuracy metric or when you have class imbalance problem. Is that clear, Nakina? So far that is okay?
Yes, sir.
Yeah. Okay. So what I'm going to do now is I'm going to stop the recording.